subtracting polynomials. So very similar to addition and subtraction when they are straightforward. We're looking for like terms. Remember, like terms have the same variable to the same exponent. So those would be like terms. And then we know that constants are going to be like terms. When we have like terms, we want to combine their coefficients. So we look at those two coefficients, and the coefficients is negative 6x squared and negative 3x squared. Negative 6 and negative 3 makes negative 9x squared. Remember, that does not become x to the fourth. And then the two constants that we have, positive 7, negative 3, gives me positive 4. Remember, our solution, our answer, must be in standard form. Standard form means that the variables come first alphabetically, and then your constant will always be last. So we should be really proficient at this point because of the addition subtraction. It's when we have two binomials subtracting each other, adding or subtracting. So remember, when we had that addition sign, we had to distribute. Well, same thing. We're distributing that negative 1 times. So we're going to distribute a negative 1 into the two terms inside of here. So it's negative 1 times negative x to the fourth and negative 1 times positive 3x. And what that really does, the shortcut is, we're going to change the sign of those two terms inside there. Whenever we multiply anything by negative 1, it just changes the sign. If it's positive, it becomes negative. If it's negative, it becomes positive. When we distributed the positive 1, it didn't change the signs because anything times positive 1 will give you that original thing. So it does not affect the two terms in front, but it does remove the parentheses. So negative 1 times negative x to the fourth gives me positive x to the fourth. Negative 1 times positive 3x gives me negative 3x. You'll notice that we changed the sign. Negative became positive, positive became negative. So all we're doing is changing the signs inside the terms, inside the parentheses. So now we look, do we have like terms? Yes, we have like terms. We have, whoops, didn't mean to do that. We have x to the fourth and x to the fourth. We have 5x to the fourth and positive x to the fourth. And then we have positive 1, that doesn't have a partner, and negative 3x, that doesn't have a partner. So we're going to combine the like terms. We have these. We will combine their coefficients. 5 and positive 1 makes 6 x to the fourth. And now we want it in standard form. So I'm going to do the other variable and then my constant. My constant's always going to come last. And notice we have x to the fourth and x to the first. So x to the fourth is always going to come before x to the first. And these are not like terms because it's to the fourth and to the first. So we can't simplify this any further. We would keep this as our answer. Again, the first step we're going to do when we have subtraction sign outside of parentheses is we will distribute that negative sign into the parentheses. So it does not affect the first polynomial. And now 4r to the fourth becomes negative 4r to the fourth. Positive 3r becomes negative 3r. Now we're looking for like terms. We have negative r to the fourth, negative 4r to the fourth. We have positive 6r and negative 3r. Those are like terms also. So negative r to the fourth and negative 4r to the fourth makes negative 5r to the fourth. Positive 6r and negative 3r gives me positive 3r. It's in standard form, descending order. And the last one we're going to do is this. So that becomes negative 8a to the fourth plus 4a squared. The opposite of negative a squared is positive a squared. The opposite of negative 5a is, or 5a to the fourth is positive 5a to the fourth. Let's look for like terms. We have a to the fourth, a to the fourth. We have a squared, a squared. So let's combine their coefficients. That gives me negative 3a to the fourth. That gives me positive 5a squared. Descending order. Good. Pretty straightforward. Good luck. Let me know if you have questions.